So the next idea spans several pages here, and what we would like to do is list all the possible subsets of a particular set, and then from this we're going to generalize how we can figure out how many subsets there are from a particular set and also how many proper subsets there are. Maybe you've already deduced so far that there's going to be one less proper subsets than subsets, right? Because a set cannot be a proper subset of itself. Okay, enough of that. So we have these different sets we want to consider. We're going to list all the subsets of set E. So since set D has two elements, we would have a subset with no elements. We all know that as the empty set. And then we could have subsets with one element. So we could have a subset with 6 in it, and a subset with 8 in it. And then 2 elements, well, wouldn't that be the set itself? All right, and then next it says list all of the proper subsets of set D. And the hint is what should be missing compared to the subsets of D? Well, we are going to include all of these except for the set itself for the proper subset. So that would be the empty set, the set with 6, and the set with 8. Okay, now we're going to look at set B, and set B has 3 elements, okay? So the number of elements of 0, well, that's going to be the empty set again. And the subsets with 1 element, well, that would be a set with 4, a set with just 6, and a set with just 8. So we have 3 subsets with 1 element. Okay, how about 2 elements? Well, we have 4, 6. Okay, now what else can we pair 4 with? We pair it with 8. And then let's skip on to 6. 6 can be paired with 8 as well. I believe that exhausts all our possibilities. Recall that 4, 6 is the same set as 6, 4, so we wouldn't want to list those again. And then lastly, the subset with 3 elements would be the set itself. Remember, every set is a subset of itself. All right, then on D, they're asking us to list the proper subsets of B. So that's going to be everything but the set itself. All right, so I'm going to pause this and you could write those down yourself. Okay, hopefully we got the same thing there. So we had everything listed except for the set itself. Okay, set C is going to be a little bit less fun because now we have 4 elements. And so I think you could figure out that the number of subsets will be increasing exponentially here, as we will soon find out. So we all know that the set with 0 elements would be the empty set, and then the 1 element subsets. Okay, the 2 elements. Okay, let's start with 4. Let's pair that with 6. Let's pair 4 with 8. Let's pair 4 with 10. We all, I think, are pretty sure that all these aren't going to fit into this box. All right, so 4 has been paired with everything. So now let's look at 6. It's already been paired with 4, so 6 and 8. 6 and 10. Okay, 6 has been paired with everything, and then now let's go with 8 and 10. All right, 3 elements. I'm going to even scooch over to the number of elements column here to make sure I have enough room. So let's start off with 4, 6, 8. Okay, what else could 4, 6 be grouped with? 4, 6, 10. Okay, what else could we do with the 4? Instead of doing 4, 6, we could skip on to the 8. So 4, 8, 10. Okay, I think we're done with 4, so now let's start with 6. Okay, I believe that's it. All right, and then lastly, the only set with 4 elements would be the set itself, because set C has 4 elements. All right, instead of making you write all this again, F says, which of the sets listed in Part E is not a proper subset of C? Well, we know that a set cannot be a proper subset of itself, so clearly the set with all 4 elements is not a proper subset of C.